John C Taylor has spent his life turning his dreams into reality. Aragon Moor is one of his proudest creations. A home he built from scratch and one of the Isle of Man's most beautiful locations. Ever since his early years, he's had a passion for making things that are truly unique. And he's constantly fulfilling his ambitions with new inventions that have changed the world. From inventing the controls for the automatic kettle to designing the world's most original clock. Dr. Taylor is a creative genius, and he's never stopped inventing things. Hardly surprising then that Aragon Moor has many outstanding and unique features. A tailor-made home by one of Britain's greatest inventors.
I've had a lot of fun in my life trying to change the world in my work, and then my passions outside work have been flying and clocks, and this is part of my clock collection. We'll see some more of my clocks later, but in the meanwhile we're going to start off going down to the hangar to see one of my other passions, flying, and then to the workshop to see the manufacturing.
A short drive from home here on the Isle of Man is John's private aeroplane. He's been flying for 60 years. It's a passion that gives him great pleasure, as well as being a huge asset for a much-travelled businessman. In the summer he'll be heading to America to fly home a Husky, a classic two-seater. Meantime, this impressive bird is clearly John's pride and joy.
So this is Musker, and this is where the turbine is hidden away. It's remarkably small, and the actual engine is right inside there. So it's quite a small engine to produce 850 horsepower. But its wonderful thing is that it's got about half the parts, well, less than that, of any piston engine, and you haven't got all the pistons having to change direction all the time, so it's very, very smooth and quiet, and efficient means of power. And a propeller on an aeroplane like this one is more efficient than a jet, up to 400 miles an hour. And this aeroplane flies at about 350 miles an hour, so this propeller is very, very efficient. And the engine is interesting because it's back to front. So the exhaust is at the front of the aeroplane, and the air comes in through the intake here and goes right round the back of the aeroplane at the engine, and then comes in at the back of the engine, and so that you can have an inertial separator. And so if you have sand or volcanic ash or anything like that, or a dirty runway, you can engage the inertial separator, and the heavy particles can't get round the corner, so they come out the bottom, whereas the air is then sucked round and goes into the engine. But when you're up high, you can then put the inertial separator into the other position, and then it's like a ram driving the air into the engine, so you get more power from the engine. It means that you can land without risking ingesting things into the engine. So it's a very efficient means of transport and great fun to fly. The thing about Musker is you put the aeroplane on rather than just get into it. There we go. I can put the instruments on for you. And you'll see the screen starting to light up, initializing the system made by Garmin. And you can hear the fan running to cool the electronics. There we go. So you've got the pilot's screen, the multifunction display, and the pilot's screen on the other side. You can't fly it without the autopilot solo. When you're at 30,000 feet, the air is very thin, and it's quite difficult to fly it by hand. But the autopilot is much better at flying than you are, so it's part of the regulations that you can't actually take off in instrument conditions without the autopilot in functioning condition. There's always something to do. You've always got to cross-check, and you're quite a busy person all the time. You can't read a book or switch off. You've got to concentrate on flying the aeroplane all the time, even with the autopilot.
I think some people would like to fly like a bird. I guess this is as close as you can get to flying like a bird.
Yes. It's more like a bird on migration than just a garden bird. It's very much a means of transport. It's the most efficient type of flying that there is. It's far more efficient than a jet, and the turbine is a more efficient engine than a piston engine, so that it's quite remarkable, the performance. You get almost 10 miles to the gallon at 30,000 feet, carrying 6 people, and not many motor cars will do that.
And do you see a lot of traffic?
No, not at all. And of course, when you're flying on the airways, the whole of the system is set up to make sure that you are separated, that you don't rely on Mark 1 eyeballs. It's all radar controlled, and controllers on the ground feeding you through the air, safely separated 5 miles or 1,000 feet from any other aeroplane.
So you have to plan ahead?
You have to apply to enter the airway system and plan ahead, yes.
Sometimes in the movies we see guys commandeering a plane. In real life, clearly, it's not quite that easy.
No, but I suppose if you commandeer a plane, you're not really worried whether it's legal or not. It's better equipped than most airliners, and so you've got the completely separate systems, one each side, but you can transfer them one to the other. And then you've got all the engine instruments here and the navigation, but you can then change it so that all the information comes onto the one screen. Here now you've got the flight plan and the map of where you are. Here we are at Ronaldsway, and the flight plan is showing how you go from there. Often you get commercial people coming to look in, and they just can't believe how well equipped it is. And the other unique feature on this size of aeroplane is down here I've got an HF radio. All normal communications are on VHF, which is line of sight. But the HF radio, where it bounces around between the ionosphere, gets great distances. So when you're flying, you could talk to America or Australia, bouncing around the world. It's very rare to find such a piece of kit in any aeroplane.
And how will this plane compare to the Husky?
Well, it goes 3 times as fast, but the Husky will have similar versions of this type of navigation system.
John started flying as a teenager, and he was hooked by his father, who was also an accomplished pilot. He was always destined to own his own planes, this a previous aircraft owned by Dr. Taylor. So is flying his biggest passion?
I suppose it is, yes. It's lasted for 60 years. I don't look back in life. I don't look back and think, oh, if only I could go skiing again, if only I could go mountaineering, oh, I'd love to go rock climbing again. I've done that, and I've got the T-shirt. So you find something else that you can do and really have fun in life. What's the point in looking back when you can still look forward? So you just make sure all the switches are off. We've got the avionics switch here, switch that off. Switch off the generator and the starter and the main switch, and then that's the crash bar, so that if you pull that down, it switches off everything. Okay.
Next stop is the factory and the nearby workshop that brings to life John's many inventions. Pilot, inventor, horologist, he's multi-talented.
Welcome to Balfane. So we've come down to Balfane, which is an industrial estate near the airport in the Isle of Man. And here we've got all the equipment necessary to manufacture anything in metal. They're all precision computer controlled machinery, and we've got some very skilled people on the Isle of Man here. I don't know what my most famous invention is. I'm well known for being involved with kettle controls, but my most useful invention, I think, is this little bimetal blade that I invented in the 70s. It has a center leg which then is used as an amplifier to create more movement out of a piece of bimetal when it goes click. And we can make it actually perform, holding it so I don't burn my fingers in a pair of tweezers. And you can hear it go click, click. And if you put it on a cold surface, it'll jump up. So the bimetal here is a heat engine because it changes heat into motion. And you can use that then to switch off a thermostat, switch off a kettle when it boils, or any other electrical appliance. And it'll do that many thousands of times. And there's something like estimating, and it can only be a mad estimate, but there were something like 2 billion of these have been made since I invented it in the 70s. If you go onto the European Patent Office and type in John Crawshaw Taylor, you get something like 398, I think it was when I looked last week. The inventions behind that are about 200 because you have to apply in each country, and so a patent in England or Great Britain you might have in France and Germany. Well, it's 3 patents, but really it's only one invention. We've gone from kettle controls to a cordless kettle at the back, to a cordless kettle in the middle, to an underfloor heating system, and then the ancillary inventions of the kettle itself, how the element is fixed, how the level indicators work and are illuminated, how scale is kept in the kettle, all sorts of inventions like that. And so it becomes a raft of patents rather than just one particular one. I never liked doing what anybody else has ever done, and so if I was going to make a clock, it had to be completely different. I needed a new way of telling time, and I wanted the clock then to look different and be interesting, that would catch people's attention. And so I thought it'd be interesting to turn Harrison's invention of a grasshopper escapement, which I'm sure only 1 in a million know how it works, turn it inside out and then enlarge it 50 times. And so instead of being against a little gear the size of a 50p piece with the little grasshopper on top, now it's 1.5 meters in diameter with a meter chronophage on top, so that you could actually see how his invention worked. And so that was the basis of starting off on the chronophage. It's quite easy to come up with all sorts of ideas. The difficulty is to change the idea into practical reality. And this workshop enables you to make prototypes and prove your idea and make it into a working model, and then you can see the invention actually works. Whereas an idea is an idea is an idea, and that's it. We're still using the workshop to make the parts for the chronophage, and as a glimmer in the back of my eye, I'm trying to make a solar cooker, which would be used in third world countries, particularly in disaster areas, And it ticks all the right boxes because solar cookers relieve the deforestation of places like Africa, that whole forests are being cut down, turned into charcoal, sold to the local people, and when it's all gone, it's all gone. So that it's essential that other ways are found for cooking in places like Africa, because you can't go on deforesting. And then the other problem is using things like dung to cook on, that in India it's traditional to burn dung. Well, the fumes and so on, there's an incredible amount of cancer induced even into children who are near the cooking fires. And it all comes back to drudgery for women, whereas a solar cooker, you've got free heat, it's all there.
The motivation to create new inventions for the benefit of mankind is a never-ending passion for Dr. Taylor. His fascination with clocks is inspired by the impact of their very creation.
It's impossible to imagine a world without clocks. It's impossible to imagine a home without clocks. People say the most important invention for mankind was the wheel. I think that's untrue. I think the invention which changed mankind most of all was the clock. The wheel is the servant of mankind, but clocks control mankind, and you can't imagine what life was like before you had clocks. It's everywhere now. It's on your wrist, it's on your telephone, it's on your coffee maker, it's on your television, it's everywhere. It's a completely different world.
Not only has he made his own contribution to the history of clockmaking, John C Taylor is the proud owner of arguably the world's most comprehensive collection of clocks.
So this is a fascinating clock made by Azurus Fromentile, and if you look at it, it's very easy to think that it's saying the time is 20 to 8, but it's not, because if you look very carefully, the minute hand goes round 4 times in an hour. So you're actually at 1, 2, 3, 4, 5. It's 55 minutes past 7 or 5 minutes to 8. Whereas you wouldn't recognize that, but it's the experimental clock. It's a very, very early clock made in about 1658 by Azurus Fromentile. And it's the most beautiful case, isn't it? The Corinthian capitals, the swags, the finials, and the wonderful spandrel engraving, and the Tudor rose in the middle. The only drawing of a clock from this period occurs in the archives of the Royal Society, and it was made by Sir Christopher Wren himself. So it's quite probable that all these early clocks were designed by the architect, Sir Christopher Wren, or his assistant, Robert Hooke. And they're beautiful little buildings in their own right. It's a beautiful clock. So this is another very interesting clock made by John Fromentile, who was Azurus' son. And you can see it's just on the cusp of change. It's a perfect architectural clock, but it's not in the black ebony. And so it's the first change away from classical gold, silver, black to the furniture of the day. And the clock led the furniture rather than the other way around. So the very early days for walnut to be used in furniture. And yet here is a walnut clock made by John Fromentile in about 1670. So I've taken the hood off the John Harrison clock, made in 1726 or thereabouts, and it's the first mechanism in the world designed to be low friction. But if you look at the mechanism here, it has the first grasshopper escapement. And so the whole thing was made by a carpenter in the early 18th century, and it was more accurate than any clock made in London at the time, and became the most accurate clock in the world for 150 years after it was made. What inspired me to produce the chronophage? I suppose modern art. I complain about modern art because I think a lot of it is the king's clothes, that there's nothing to it. But it's one of my characteristics. It's no good complaining about something unless you're prepared to do something about it. And so I set myself the task to think of how to create something which was modern art and yet actually did something. And time is not on your side, it's rather scary. So I changed the cuddly image of a Walt Disney grasshopper into a rather frightening time eater. And I thought it'd be fun if in a minute he slowly opened his jaws wider and wider, and on the 59th second of every minute he went, ah! And he got that minute, he chewed it up, and he swallowed it, and then you could never get it back. I think it's very difficult to judge one's own inventions, and you're always very proud of what you've done. But the only proof of the pudding is in the eating. And if other people appreciate what you've done, then it gives you an even greater satisfaction. I can go to any high street anywhere in the Western world, and in a shop window selling kettles, I can say, I designed that one, I designed that one, I designed the controls, yes. And that gives you a wonderful pleasure. It's the same in the chronophage. If there were museums or institutions or individuals who appreciated it, then it would give me great pleasure.